Yeah, sorry.
Okay. Okay. When I
It's
think
okay if we
about
record, right?
when I think about the science that's needed or ideal to have during an oil spill event, you have to differentiate the science that you would do during a response, during the forensics, and also to assess damages. Almost always, having a pre-existing relationship with working with other people will lead to a better outcome. In my professional career, I've yet to work on an oil spill where the early predictions of what was going to happen in the first couple of days ever occurred. Just to remind you that when the media and other folks present what's going to happen during an oil spill event, they're usually over the top. That's not to say that we're discounting them. And then last, during any crisis, but even in this case, oil spills, there's always this trade-off between time and uncertainty. If you had more time, you usually can be more certain. Not a lot of time, you're going to be less certain. And there's trade-offs in dealing with the time versus uncertainty. So those are my takeaways. I'm going to touch upon them a few times, hopefully throughout the night, actually. So just remember, when there's an oil spill, the overarching goal is to make a bad thing from getting worse, right? There's no happy endings at any point. You want to use the best science and engineering and other aspects you have in hand to make an unfortunate event not get any worse. Just it's always your mindset, making a bad thing from getting worse. So I'm just going to start off after getting that bad thing from getting worse into your head. I live and work at Woods Hole Oceanographic Institution in Massachusetts in the United States. It's about 1,200 employees. We're one of the largest marine research institutions private in the world. And I've been there for almost 26 years. And I principally study, here we are in the United States, where that black arrow is where I'm at right now. So my research interests are really looking at pollutants, whether it's oil spills or plastic or deep sea waste. And I have an interest about using that information either in the short term, like how do you stop this unfortunate event occurring, but also in the long term about taking the knowledge of any one unfortunate event and perhaps making something better because of it. So I'm going to talk a lot about oil spills, about using the science we have in hand to make a bad thing from getting worse. But I spend about half of my time also trying to generate maybe new fuels, new plastics, or even new sunblocks based on learning from about past chemical spills and events. To me, when I think about an oil spill, I think about it as putting nature on a treadmill. That you have this uninvited guest who's now putting stress and strain on your ecosystem and on the earth on a larger scale. And so it's an opportunity for us as scientists to also understand how nature works and learn about the actual natural aspects, about what does nature have in its toolbox? Where does nature show its resilience and where it doesn't? And that's always kind of my mindset is that any oil spill is just a rather extreme event of highly reduced carbon input into in most cases, a coastal environment. But it's an opportunity to see how nature responds and learn from it. So I've been working on oil spills and my first oil since the late 90s. And I'm going to go through a couple oil spills that I've worked on or contributed to, and then I'm going to come back and return to them throughout my tonight. So this is the North Cape oil spill. It actually was a barge ran aground, and it lost about 700,000 liters of diesel fuel or home heating fuel in Rhode Island, which is not too far from where I am in the United States, in 1996. I also worked on a barge that ran aground, again, not too far from where I am, called the Bouchard 120. Much smaller volume of oil, but it was from a barge that ran aground. This is the Costco Busan oil spill. The Costco Busan was a cargo ship. that was leaving Oakland, California, heading west. And before it hit the Oakland Bay Bridge, not the Golden Gate Bridge, which is what you see here, and opened up a couple fuel tanks. So these first two spills I talked about were actually oil barges. They were barges that were carrying oil to be delivered. This was a cargo vessel that leaked oil. Sorry. Then I spent about a lot of time in my life studying the Deepwater Horizon oil spill, which happened in April 20th, 2010. One of the largest oil spills in history, about 160 million gallons released over 87 days. And I spent about 7 or 8 years of my life studying different aspects of that spill. And this was in the Gulf of Mexico, again, in the spring and summer of 2010. Then after the Deepwater Horizon in 2014, I studied another oil spill, another fuel oil, which is the fuel that either is used to make energy at some power plants, but in most cases for, moving ships, fuel for ships. This was in Texas, not too far from Houston and Galveston, Texas. Then I was involved a little bit more closer to where you are, looking at this furnace oil spill in Bangladesh. And furnace oil is kind of like fuel oil. It's a very heavy product that's used to burn to make energy, either for heat or electricity, but also for propulsion on boats. And then more recently, I haven't done as much science on it, but I also helped out the Russian Federation, in this case up in Siberia, where a diesel fuel tank was destabilized due to thawing of the permafrost, and then had a massive release of diesel fuel in this river. Then I've been working and analyzing, just got a new batch of samples from Mauritius, from the Wakashio. Again, the Wakashio was also a cargo vessel. Had about 1 million gallons of oil on it. That was the fuel. They get it from one place to the other, and it ended up releasing about 250,000 gallons. Of course, very close to shore near coral reefs. And then I've been working a little, much closer to home for you. Again, oil spill, plastic spill, many other chemical spills. One of the first oil spills I actually worked on was looking at the oil residues from a diesel fuel spill that happened in 1969, where oil still slightly remains. And then I have an ongoing project looking at oil that leaks from the USS Arizona, which was an American battleship that was sunk when the Japanese attacked Pearl Harbor on December 7th, 1941. And it continues to leak oil every day. And a little bit more closer to you folks, I advise and help out here and there with the FSO Safar, which is off the coast of Yemen, which is carrying some amount of light crude oil that the UN is currently trying to remove, although it's a little tricky. So I just walked you through about, 7 or 8 oil spills. And I think what you might have noticed is that a lot of them will look like a ship and oil on the surface. And, one would immediately think that all oil spills are the same. But every one of these spills that I talked about had a very different outcome. Different fuel, different volume, and different location. And all those factors ended up really underscoring the point that every oil spill is different. And while you can use the knowledge you've had fighting the last one or somebody else's efforts, you have to be nimble enough to recognize that every spill event is going to be a different set of challenges and demands and opportunities. So just as that kind of a warm up, I want to just go through an outline for what we're going to talk about. I want to really drive home these 3 key concepts of volume, location, and oil type. Then I want to tell you a story about how I made a real fool out of myself in 2003. And then I want to go back and talk a little bit about the different types of people and interest groups that are involved in a crisis. And then I want to end up at the end talking about the mindset and the science and the approach of when you do science during a response versus the science during a damage assessment. So I want to jump in and talk about volume, location, and type of oil. And these are like the three questions you want to ask or start thinking about when you have a spill event. And I'm going to start off with volume spilled. If you read in the newspaper or you hear on the radio or wherever you get your information about the newest oil spill that happened, they'll say, this barge leaked 1 million gallons of oil. And then for the most part, surprisingly, they will say the Exxon Valdez, which happened in 1989 off the coast of Alaska up in the United States, spilled 12 million gallons. And then there's a perception and kind of a tone and interpretation that if this spill is only 1 million gallons and the Exxon Valdez was 12 million gallons, then this 1 million gallon spill is only going to be, a little less than 10% as bad or as hard. So there's this ongoing perception that volume is the most important factor, and that if you know the volume, then you're extremely well positioned to predict what the outcome is going to be. And while volume is valuable, of course, it's a key player, it can be deceiving. Because the challenges and the impacts do not scale linearly with volume. And, there's a lot of other research papers out there, but I just want to make a small point and just comparing two spills that I worked on, that I was on site collecting samples very soon after. I was walking around towns, I was eating in hotels, I was meeting with people at two spill events. One was a Costco Busan spill, which happened in San Francisco Bay in 2007. This was a spill that everybody could see, but it was only 58,000 gallons of fuel oil. And while it was disturbing to look at visually, there was a lot of folks saying, well, it's just 60,000 gallons of oil. And the Exxon Valdez was 12 million gallons. Why are we making such a big fuss? Well, in this case, there actually was a lot of sensitive species, fish species swimming around at the time the oil was released. And while numbers are a little confusing to work out, this was an extremely damaging oil spill, even though it was only 58,000 gallons. It happened to be 58,000 gallons in a location that had great impact to certain fish, but also kind of the economy because everybody could see it. Now we can contrast that with the Deepwater Horizon, which released about 160 million gallons of oil for 87 days. And when people started talking about this event, there was discussion that the Gulf of Mexico would be dead for decades and decades and decades. There was this idea that the volume was so large that the world was going to end. I'm being a little over the top, but it was true. The way people were talking, it was so over the top and so defeatist. And while, it is hard to predict the outcome, you have to be really careful about predictions that folks make because they matter. They matter about the people and the lives who are impacted. And one of the reasons why the Deepwater Horizon was not as big or as bad as what folks predicted is in part due to location. So that's my second point. So volume matters, but it doesn't necessarily always scale. Okay, that 160 million gallons must be, 15 Exxon Valdez. It doesn't work like that. Everyone's different. But I want to draw your attention and transition from the Deepwater Horizon in terms of volume to location. Because in my mind, I actually think location is as important or more important when you think about an oil spill. Where does that event happen? Because that event, and actually where and when, drives a lot of key factors. The sensitivity of the area, the timing in terms of how you can get there, but also the timing in which maybe some species is moving through the water at that time, the available resources, which could be boats, could be people, it could be knowledgeable people, and then also the infrastructure, the capacity to actually bring on and fight a battle, to have boats in theater, helicopters, the capacity to feed and bathe, and all these things that you need to have a successful outcome is all driven based on the location. And I'm going to give you kind of a run through from the Deepwater Horizon, which for the most part was not as bad as folks predicted. Really bad, but not as bad as predicted. And there's a lot of reasons. I would say that the ocean is remarkably resilient, but I think there are other factors that put in play that underscore the significance of location in terms of trying to gauge an oil spill's outcome and also learn from them. Again, this is the Deepwater Horizon. It happened in April 2010, about 25 miles off the coast of Louisiana in the United States. A well was broken. It released about 60,000 gallons an hour of oil and natural gas as well for 87 days until it was shut in. You looked on the video, you looked on TV, it was absolutely devastating to look at. But it wasn't as bad as folks predicted. And I'm going to argue that a lot of it was driven by location. It was the Deepwater Horizon here is in a yellow star. And the blue is the northern Gulf of Mexico. You know, the landmass here is all the United States Gulf Coast area. The Deepwater Horizon is the yellow star again. The Deepwater Horizon blowout, that was a drilling rig. The well was called the Macondo well. I would argue was close to land, but not too close. It was close enough that you could get boats and people there in a timely manner to fight this battle. But it wasn't too close that the oil was overwhelming and in the faces of the land and the people. So there was just enough space to provide a buffer, but not too much space that it would detract from being able to actually attack and try to put this spill out of its misery. The Gulf of Mexico was actively a drilling area. There was an extensive amount of pre-existing knowledge and relationships with a whole wide range of communities. This was an area that had been drilled for oil for decades and decades. People knew about oil spills. People knew who was who. They just knew how the world works in terms of oil and oil spills and petroleum and engineering and petroleum geology. The outcome was you had a lot of smart people and a lot of knowledge about the area that was already existing. Okay. The Gulf Coast was populated. It had people there that could help. There were large populations there that could help and support in any way. And I think one of the most important things was there were roads, airports, and ports to be able to fight this battle and to get people in theater. And this is one of the biggest challenges when folks talk about Arctic oil spills. It's very difficult to put on an oil spill battle if you can't feed people, if you can't put them in a hotel, if you can't drive from one place to the other, if you don't have cell phone connections. All of these are factors, and they have nothing to do with the volume of the oil. And then in the United States, there's kind of a, I guess, semi-fast food restaurant called Waffle House. And if you drive around this aspect of the United States, there's one about every mile or half of 2 kilometers or so. They're everywhere. And to me, what this matters is that you can feed people. And I'm going to continue to remind people that when we think about oil spills, we often think about oiled birds or mammals. And I like to think of them more about people, about the people who are going to be stopping this from being a bad thing. And also as people who are, in most cases, the most impacted species of an oil spill. Whether or not it's their economy, whether it's their social lives, their cultures, always remember to put people at the top. They're the ones who are going to make this get any worse. And those are the ones who are, I believe, in most cases, are the most deeply affected. Again, the Deepwater Horizon was not as bad as, for a lot of reasons, but I think a lot of it goes down to location, resources, people, and pre-existing knowledge. Again, this is an overlay of all the things that were going on before the Deepwater Horizon happened that led to something that wasn't as bad as predicted. Then we're going to talk about type of oil, and I'm going to run through this kind of quick, but every oil is different, has a different composition, which means it has a different, which demands a different, potentially different response. That is, how are you going to combat this and make it go away? It's going to have a different fate, and it's going to have a different short and long-term impacts. Ultimately, when you hear that it's an oil spill, the next question you should ask is, what type of oil is it? Is it crude oil? Is it gasoline? Is it diesel fuel? Is it fuel oil? Because ultimately, that will determine how you combat this event and decide how are you going to make this bad thing from getting worse based on what the chemistry is. And you folks have probably seen and heard about gas chromatography, but just to make a point, you can analyze most fuel oils with a gas chromatograph, which allows you to take a complex mixture like oil or a fossil fuel product, separate it, quantify it to your best as possible, and have a visual representation about what is the population and the relative abundance of different compounds that are in your fuel product that got spilled. And I'm going to walk you through a couple chromatograms, not really to give you a quiz afterwards, but just to have an appreciation, which goes to underscore to you have a different product depending on what event happens. So we're going to go back to just look at some gas chromatography flame ionization detection chromatograms, or GCFID. And they're just pictures about what is the inventory in this oil. This is the chromatogram from Deepwater Horizon. On the x-axis is either time it takes to be separated in a column, or the relative amount of carbon numbers that those peaks represent. So the compound that's around 27 minutes has about 20 carbons in it. And on the y-axis is just the relative abundance. So this is the distribution and the relative abundance of the compounds that were leaking from the bottom of the seafloor for 87 days in 2010. This is diesel fuel. Actually, a diesel fuel from one of the fuel stations near my house, but it's different. It has a much shorter boiling range, has a different processes, different fate. Diesel fuel is very different than crude oil. I'm going to walk you through a bunch of fuel oils. Remember now, fuel oils, it's the oil that powers most ships now, whether they're cargo vessels or even tankers. Now, since January 2020, there's a low sulfur fuels that are out there, but the key point is that fuel oils are always different. They're made at the factory, at the refinery, depending on what you have. So I'm going to take you through and show you chromatograms of fuel oils from fuel oil spills. This is the Bouchard 120, happened in 2003 in April. This is the chromatogram for that spill. This is the fuel oil taken from the number 4 port side tank from the Costco Busan, which spilled in San Francisco Bay in 2007. When the boat ran up along the bridge, it opened up 2 tanks, tank number 3 and tank number 4 on the port side of this cargo vessel. This is the fuel that was getting it to cross the Pacific. This is what was in tank 4. This is what was in tank 3. Now, 2 very different fuel oils. So let's just stop right there. One vessel hits one bridge, opens up 2 tanks, both fuel oil, different compositions. Part of the challenges of working on an oil spill, not only you might have a different type of oil, you might have different types of oils and different tanks on your boat. Comes to find out that most of the oil that got released was from tank 4. Thankfully, there was some good fingerprints within that we could disentangle and work out that it was mostly from one tank. Point of the matter is, fuel oils differ. The fuel oil on one boat may differ from one tank to the other. This is the Prestige, another fuel oil. This is from 2002, a spill that happened off the Iberian Peninsula, impacting Spain and Portugal. And then this is the Kirby barge, which happened in Galveston, Texas in 2014. Now, I got these little panels in between, but if you scroll through them, these are all fuel oils which is what, then unless you most likely don't have any refineries going on near your nearby area, most of your oil spills now are going to come from cargo vessels or vessels carrying fuel oil. You have a very high incidence of fuel oil releases, and they always differ because they're made up at the factory depending on what the refiners have in hand. Every one of these products, all these chromatograms I'm showing you, they have different compositions, which in turn changes their fate, how you respond to them, and what are the short and long-term impacts. You just have to be mindful of knowing what you're battling against. In the United States and in other areas, when an oil spill happens, most cases a sample is collected and sent to a lab to get as rapid of analysis as possible so that you have the most well-informed response. Sometimes that doesn't happen, in part because sometimes there's a spill and somebody will say it's a diesel fuel spill, and they start responding to it thinking it's a diesel fuel spill, but it's not, it's a fuel oil spill. So often having the analysis helps you decide this response. Just for fun, we were looking at an accidental coal tar release in Texas, and this is a chromatogram from coal tar, which is kind of the residue after pyrolyzing coal, and it's the kind of stuff like you might see the waterproof, like at docks in areas like that. So we talked about the value of knowledge, knowing how much was spilled, the location matters, and the type of fuel. These are 3 things you want to keep in mind when you have an event. I'm going to do one more walkthrough, and then we can take a break and ask questions. I'm going to tell you about some mistakes I made working on this oil spill that happened in 2003, the Bouchard 120 oil spill. It happened literally in my backyard. And what I did and the mistakes that I made, which I think are really critical to understanding what happens during a response. Bouchard 120 was it was a barge carrying oil, fuel oil, that was had about another 20 or 30 miles to go, and it was delivering fuel to a power plant that created the electricity for where I lived. And it ran aground while it was near a shallow area and leaked oil. And it happened on a Sunday night. And by Monday morning, I was on a boat collecting samples and doing my best to figure out what was spilled and speaking to the media because people wanted to know what was going on. And I was doing everything. I was collecting samples in the daytime, analyzing them at nighttime, doing everything. But I thought I was doing the greatest job ever. And this was on a Monday. 5 days later, I was invited to kind of a town hall meeting in an area at a big auditorium. And I was invited, and it was a big meeting about, from the United States government and local and town officials and industry people, and actually the people who lived nearby. Everybody came. It was supposed to be this big briefing. And I was one of the speakers. And I was really excited. I thought it was super cool that I was showing my data. I thought it was a game. I was so excited that I was the first one. I had all this data. And that was one of my biggest mistakes. This isn't a game. It wasn't a game. I thought I wanted to be in the newspaper. It wasn't a game. This was people's lives and livelihoods were on stage. So I went up and I gave this talk about the samples that I collected 5 days earlier. And I thought I was so great. And I showed some really cool chromatograms called comprehensive 2-dimensional gas chromatograms. Much, much more sophisticated, much more insightful, really kind of cool stuff, much cooler than those GCFID traces I showed a little bit earlier. And I was showing this whole group of people who fished the water, and policemen and firefighters and the local people. I showed them this chromatogram, and then I said, but look at this sample. This is the sample collected right after the spill. And then look at where all these compounds are. And this is an aromatic. This is a biomarker. And then I said, I'm going to study this spill. Now I'm talking to these people, the oil is still floating in their backyards per se. And I went and I told these people who are hungry for knowledge, I said, I have the coolest instrument in the world. And in about 5 years, I'm going to be able to have the most refined weathering profile. I'm going to be able to tell you where all the oil went, part one. Part two, I'm going to be able to figure out how much of the oil evaporated versus how much got dissolved in the water. And part three, I'm going to show for one of the first times that microbes are actually eating this oil in real time. All these people came on a Saturday morning to learn about this oil spill and whether or not they should be selling their homes or whether or not they should go on vacation someplace else. And I told them this is what they were going to get, but they had to wait 5 years. And I showed them all these ideas, and comes to find out, I did it. I wrote the paper that came out in 2006. I said, I'm going to apportion all this stuff. I'm going to do this. I'm going to do that. I wrote a paper in 2006. I got best paper in the cover. Wrote another paper on this. Wrote another paper on this. Then I said, I'm going to trace the carbon into microbes. We did it. We wrote papers on it. I thought that morning where I predicted what I was going to do in 5 years, and I did. I thought I got an A+. I thought I was the best person in that room. And now I failed. I know I failed. This is now 2023. I failed, and I found out in reality about half an hour after my lecture. They had people out in the hallway, and people came up to me, and this one person came up to me. She goes, I have no idea what you talked about, but you have the coolest graphics. And then another person came up, and it was a husband and wife and 2 kids. And the guy asked me, I fish these areas. This is what I make my living on. When can I start feeding my family? And I didn't have the answer. All I want to do is show them my chromatograms. And I failed because these people came for information that they wanted to know right then and there. And I was promising something that they'd have to wait 5 years for. I kept trying to offer them some gourmet food that you'd have to wait and wait and wait. And they just wanted comfort food. They wanted to know what I could tell them at that moment. They didn't want to know what would they need to know in 5 years. But on the flip side, nobody asked me in the response. I did all this science by myself. I was just some academic with access to a boat and some jars and chromatograms. I had no relationship with the response community. I just was out there doing my own thing, talking to the media about it, and, asked to give a briefing. And I ended up doing some really good science, but not in a useful manner during that response. So the key point was for me was that I learned after that working on oil spills is an opportunity to make a difference, but it's not a game. It's not a chance for me to be in the newspaper. It's not a chance for people to tell me how smart I am. But more importantly is that in the early stages of an oil spill, people want to know something. What they don't want to hear is, if you wait in 5 years, I'm going to tell you the greatest story ever. Folks want some level of certainty. They want to know what you know with some level of certainty. And you want to know what you don't know and what's changing and what's under the debate. And for me as an academic, my biggest fails is that I am fine waiting. But if it relates to your everyday life and your lives and your livelihoods, folks don't want to wait. And so you have to be mindful that when you're in the early stages of an oil spill and when information is needed, you have to have a timely response, and you have to provide information that is useful, right? If I had told those responders that I use this really sophisticated mass spectrometer to show that this one type of microbe was eating this oil, the responder would say, I don't care. I don't care if you used an accelerated mass spectrometer or a kitchen blender. all they want is information to make a bad thing from getting worse. And so whatever the information that you're generating, you have to be mindful about who might use that if you're trying to make a bad thing from getting worse. So I'm about halfway through. Mahini, is this a good time to stop and maybe take some questions?
Yeah, I think so.
Okay. How's it going? I can't tell.
I know it's going great.
I have no idea.
Sorry that you can't see everybody,
Yeah,
but
you can just repeat the questions if there's any, if there are any.
yeah. Anyone have any questions or comments, or I think Chris would be happy to address them. So one of the big points that he made was the difference between kind of how much oil spills and where it spills, and did he make that point effectively? Do you kind of see the impact that it doesn't sometimes matter how much spills, it's really what the ecosystem might be, or who's living in that area and using the ocean as a resource, like for fishing? And I think that's a really important point with respect to kind of what could happen around Sri Lanka. Are there any comments about that? I think also, I know one of the requirements for this training, or one of the requests, was to talk a little bit about how you look at the composition of oil, at these SOPs for oil composition. And I think, what Chris shows really effectively there is that a simple instrument like a gas chromatograph FID, which is really easy to maintain, is really effective at showing the differences in the fingerprints. And it's very easy to teach someone how to interpret those data, how to collect those data, and also how to maintain that instrument. And I think, Chris, you were saying that in the US, when an oil spill happens, you take a source sample right away and you send it to this lab in Louisiana, right? And their thing is a GCFID in 24 hours.
Yeah. So in the United States, and I know in other places, there's a very strong effort to collect the sample immediately. In one case, and we're going to get back to this later, to secure that sample, because it's so critical to various aspects. So getting a sample of oil, but then immediately analyzing it to just get any type of clue and any information that can help the response. They're not going to wait for the results, but that type of information, and for the most part, that information that is sent back within 12 hours or depending on 24 hours, most cases, most of it is built off a gas chromatograph with a flame detector that's probably 30 years old.
Yeah, right. So it's
and I'm going to talk a little bit more about technology later, Mahini, but it's a really critical point when I was talking about my mistakes, which was I thought because I was doing the most high-tech thing that everybody was going to benefit. And in reality, I was generating information that I thought was interesting, but not necessarily actionable and useful to others.
Right. And I think even with the plastic spills, right, that's one of the things that you emphasized, was getting samples really early, right, as soon as somebody could, then trying to collect samples over time, and using simple technology as possible to look at the nodules. Right?
I'm going to talk a little bit about sampling strategy and different types of samples in kind of part 2. But it's absolutely critical that if you are going to be involved in the most important thing besides being, first is always be safe. And the second part is to identify the original sample and secure it. If you don't have the original oil, and I don't know where you folks are from a legal perspective, but at the end of the day, especially in areas that have maybe previously been oiled, or you might have a ship that has 2 different types of fuel on it, having discrete samples with well-defined provenances and good record keeping is going to play a critical role from day one all the way until the spill is finally settled.
Right. And so when he says provenance, it's just where this, what the source is. So you want to be able to link that sample. With the nodal spill, it might be a little bit more obvious.
Yeah,
Right? But with an oil spill, especially in some places like the harbor here, where you have multiple ships going in and
yeah.
out, it's really hard to trace that oil back to its source unless you have a sample of what's in those source oil, because
And when,
yeah, go ahead.
and when there is a spill where there is an unknown source in the US, they will go collect a sample from every possible ship. And they will,
really?
yeah. So if there is a release of an oil in a harbor and they look at the charts and where everybody was, if there was 4 possible boats, all 4 boats will be boarded and they will get their samples collected, and then they will be analyzed, and then they will make their best possible, determination about who was the responsible party when they compare the samples collected on the ship to what was been found on the sea surface or elsewhere.
Wow, that's impressive. Okay, any questions? Yes, great. Oh, yeah, you can tell me and I'll repeat it. And your name?
I am Indica.
Indica.
Yes, I'm repeating that point.
Okay, Indica is asking a question.
All right, cool.
Thank you, sir. I'm asking.
Can you hear, Chris?
Just barely. You'll have to repeat, Lahini.
Okay.
You explain marine science, and I asked you to explain most dangerous example related to the oil spill. Then after the spill and oil, what's the most suitable and latest method to remove it from that affected environment? So it will be used in the as short example.
Which example?
During his presentation,
Yeah.
I used to incident we explain so many examples affected during the historical events. And I asked him, what's the method if
So-
they use
To remove.
a system, as I understand, we need to remove from that amount from that environment, affected environment. What's the method?
So Chris, the question is, and I don't know if you were planning to cover any of it in the next part, is once, let's say it comes on shore, right, and it's impacting a particular environment, what's usually I guess, anyway, what would the response be with respect to removing that oil, or what is even
Well,
possible?
no, I mean, this is one of the big questions, right? And this goes back to location, right? I mean, so, if you have an idea of what is the most sensitive area, right? I mean, for the most part, in most oil spill responses, they let the oil, if you have limited time and limited resources, you let the oil go on the beach because you could always bring in trucks and bulldoze it away. And that you often want to try to defend or stop the slow growing species. So these are areas where maybe you have large fish may grow, but more often than not, they try to protect coral reefs, mangroves, and salt marshes, because you can't bring in a bulldozer to take them away. Because it takes so long for them to grow. And
So they would try to put, sorry. So they would put barriers in front of those environments typically? Is that
they
what you're trying to?
they will do whatever they can, whether it might be barriers, they might be using a whole different types of booming, but whatever the case may be, there will be decisions made. We have these many boats, we have this many people. Where are we going to protect so that we don't have any oiling? And they will go to the areas that are the hardest to clean up and the slowest growers in the most sensitive areas. And that areas that are easy to access and ones that can be easily removed without damaging cultural, economic, tourism, they'll let them get oiled. And that's sometimes frustrating the people who are watching it on TV. But ultimately, the decisions that are made early on a response about the net benefit. And in most cases, bulldozing is a pretty small price to pay to take away sand if you can protect areas that grow so slow, like salt marshes, coral reefs, mangroves, or areas that might have some large fish growing. That's a little bit harder to predict.
So one precondition of that kind of response is having a really good
Yeah.
idea of what your different ecosystems look like and what you value, and then
That's
also
right.
in terms of
Yeah.
livelihood,
Yeah,
fishing grounds.
that's absolutely true. And I touch upon that a little bit later, but you know, in most areas, there are things called environmental sensitivity indices. These are maps that are made that somebody who may not be particularly local has a knowledge of the areas that are the most sensitive, the ones that may grow the slowest. But now not only do you have an environmental sensitivity index, but you also have cultural, some sense of tourism, but also these maps are overlaid with roads and cell phone coverage, because you want to know what areas are easily accessible by car and truck to clean up. Point of the matter is that a lot of decisions being made about oil spills happen to do with good maps and good knowledge of the area about what matters the most, and not as much about whether or not you're using a dispersant or not. A lot of it has to do about, and these are things that while you cannot predict and what an oil spill is going to be, you can certainly prepare and have a good understanding of the local area, what values matter, where areas that are the slowest to recover, the most sensitive, and also game out. If you only have one boat and two areas are going to get impacted, what place do you try to protect?
Yeah. Thank you. Just I have got three short questions. One
Yeah.
is,
It's Azmi.
yeah, I am Azmi. Yeah, I am the coordinator of the project in Sri Lanka. So I have been in this field for some time. So I am just asking. One is, you know, for crude oil, when they spill, or usually what we find normally is these tank washings, you know, the
Yeah.
crude oil tank washings they do in the sea somewhere, and about 3 days later they form tar balls and they come to the beach.
Yeah.
Right. So that is a frequent occurrence for the last 30 years. We don't notice much, but because there is only a few.
Yep.
And the second question is, and I want to know whether it's very common in the US and other places we have studied.
Yep.
And second question is, this oil spills that you have worked on, what is the maximum distance that was affected from the source of the spill or accident?
Oh yeah.
I mean, how far does it go?
Yep.
And the third question is, now you were mentioning about these people affected, like fishermen, tourist guides, people on recreational beaches who have different duties.
Yep.
All these are affected. So in the case of an oil spill, you know, the whole families of these people and themselves, they help to clean up, and they get some money either from the government or some other people. So each bag or box of oil they help to clean, they get money for that. So their livelihood is somewhat compensated. But in the case of a hazardous spill, some hazardous waste, then because of health and safety measures, they are not allowed to go near.
Yeah.
So
Yeah.
more trained people are given the chance.
Yeah.
So then they don't get this chance to make some money from the disaster.
Yeah.
For their livelihood, for their food and this thing.
Yeah.
So just if you talk about those three things,
Yeah.
thank you.
Yeah, no, thank you. These are really great questions. Yeah, and you know, in the 70s, there was a couple scientists who were really tracking these open ocean tar balls. And this one scientist in the US was collecting them. And, you know, his conclusion was in the 70s and early 80s that tank washing was a big source of the samples. oil that's being found along the coastlines of the United States. I kind of went back and redid it, with tar balls that were in the North Atlantic. And, it's still hard to differentiate. I will tell you though, that the incidence of seeing them is much lower, and I can send you a couple papers. But even at the end of the day, we looked at tar balls that were collected in the surface in the North Atlantic along the US coastline in the Gulf of Mexico. I think we looked at 96 tar balls that were collected in nets, and they were all different. And, that's not very satisfying, but it's a frustrating aspect because you're looking at a sample, but, as you said, 3 days later, you have the input term. So I would say tank washing is still a problem. It's difficult to identify who's their input term because you have such a long lag. And there is less being observed in the US. I can't speak for a little bit more broadly, but it still happens, and it's difficult to trace because you have such a lag time before it might be identified because you're so offshore. Going back to location, that's a great question. For the Deepwater Horizon, it depended, is an interesting case because the oil was released in both at the surface and the bottom sediments were impacted, but as well as oil that reached to the surface and then floated. The interesting thing is that the impacted area oiling from the Deepwater Horizon went from Florida to Louisiana, maybe even a little bit of Texas. I think about 1,000 miles of area was oiled on the beaches, but the oiling on the bottom of the sea floor was very small area. So the oil didn't travel as far on the bottom of the sea floor. And so one key aspect is that depending on where you were in the depths, the travel distance was differed. I would say worked on this oil spill in Texas in 2014. This barge went about 60 or 70 miles, and I down to Mexico. And there was a blowout in the southern Gulf of Mexico, the Ixtoc, which happened in 1981, and that oil flowed all the way up to the Gulf of Mexico and eventually hit Texas. And last, I have a paper that I'm just finishing up where I'm pretty sure that oil that was released off the coast of Brazil made it all the way to Florida, the United States, across the equator, absorbed to some glass and plastic bottles, and came ashore in an area that would have been predicted based on the physical oceanography. The end result is that it can travel a couple feet or a couple miles, or it can travel pretty far. Depends on the circumstances. The last point is a really hard one about people. And when I was talking about people, and I'm really happy you brought up this question, is again, I'm a chemist, not a psychologist. I'm not an economist. But I work on enough oil spills that I get really frustrated because when there's a spill that happens, there's an expert from halfway around the world who is saying that area is going to be dead for 10 years. Right? And so you're not working because you work as a fisher and your spouse works at the fish processing plant or at the local restaurant, and you're not working, and some expert is on TV saying that your area is going to be dead for decades. And the end result is, and this is very well studied, is that you have an increased amount of spousal abuse, mental health issues, emergency room visits. And so you have this sense of despair, which can be alleviated if you can get people working and try to help with the cleanup if you can do it safely, as you mentioned. So there are options in play to do that. I really can't speak about hazardous waste or otherwise, but I think the key point is to drive home really importantly is often when there's an oil spill, folks only care about the dolphins and the birds, and they and I mean, it's understandable. You see these very charismatic or heart, really tough to see pictures. But at the end of the day, most oil spills hurt people the most. They hurt their wallets, they help their livelihoods, their mental health, and what they value in their lives culturally. So there are active projects and programs during a response about trying to get the local populace involved in a safe and harmless manner. Sometimes it works, sometimes it doesn't. A lot of it has to do with timing and other factors, but at the end of the day, you do have to be mindful of people.
Okay, thanks, Chris. Any other questions? Oh, yeah, okay, great, all right. That's a pen, like kind of moon up pen on it.
Hello.
Hi, how are you?
Actually, I want to know, in our case, the big problem is in us is it is very fishing ground, and we want to know at the beginning how many area we have to restrict for the fishermen and how many days we have to restrict for their fishing activities. Actually, I have two questions. One is, in your case, how you deal with the fishermen, and have you banned any fishing duration or something? And second one is, are there any suitable model or something when we feed the data from which oil type is spill, volume, and oceanographic and environmental parameters, and after that, can we decide that to answer that what extent we should stop the fishing and what is the time duration?
Yeah, Lahini.
Yeah,
My brain is so late, I can't think.
Yeah.
The guy's name who's going to talk about The Economist. Why can't I think of his name right now?
Oh, yeah, Richard Carson. Yeah, Richard
Yeah.
Carson.
So Richard's probably going to talk about a lot of what he just said.
Okay, yeah, and we can talk a little bit.
But I think that from my perspective, I've never been involved in, any type of monetary assessment of loss of fishing. I have been involved in assessing the data that goes into deciding whether or not a fishing population gets closed, but I'm not an expert. What I can tell you, though, that it is one of the most contentious and more difficult decisions that are made in early spills because of the significance, not only that you're shutting down the fishery, but it gives a sense of real hopelessness in that decisions being made about shutting down and opening fisheries during an oil spill are some of the more difficult and more contentious. But again, it goes on a case-by-case basis. And, more often than not, and you mentioned this about modeling, is that you don't have enough data. Right? I mean, in order to make think about that, you're making a decision on shutting down a fishery that employs and feeds thousands of people, and they might only be able to collect 4 or 5 samples, and they have to send it out and wait 2 days. And these are big challenges because decisions are being made in the best hope that it's the best outcome, but in many cases on a limited amount of samples. But the hope is that they're doing their best to make sure that everybody comes out the least damaged. But these are really challenging because it's a hot topic. It's meaningful to the populace. It's meaningful to the economy. And you're not going to get a lot of great data in the time that you need, that you're afforded to make the decisions.
Yeah, Sean. There, one more question.
Yeah, no, take them all day. This is awesome.
Hello, Professor. Good morning. I am Shamali here. I have a small clarification regarding that oil spill. As Mr. Asmi already stated that there may be tar balls after oil spill. So my question is, in the initial stage, we can observe the contamination of that animal biota, fish and other turtles and marine mammals. We can visually observe. But with the time that oil is withered and only in the environment, tarbol is remain. So my question is that tarbols can be ingested with that fish and shellfish, even food fish. So is there any mechanism to identify that tarbols? Can we use that GCMS after the digestion of that fish tissues?
Yeah.
What is the procedure to identify?
Yeah, I mean, I think this is a great question. I mean, sure. And this kind of, if you have, and this is where it gets kind of challenging, right? So you're trying to identify whether or not some type of oily residue that's in a fish or some seafood can be traced back to a source oil. And it's a very challenging one for a couple of reasons. One, you still have to have the source oil to make that determination, to do it in with the best faith possible. The second thing is that by the time that sample of oil is now inside that fish tissue, it has weathered. It is not the same. Some of it's evaporated, some of it's been water washed. Possibly some of it has been biodegraded, though not likely. Some of it has been broken down from sunlight. So now you're trying to fingerprint a sample, a hydrocarbon residue that is dramatically different than what was originally spilled. Now, then you start to rely on trying to fingerprint the sample in the fish with compounds that are known to be recalcitrant. And, often they call it biomarkers or molecular fossils. And then you're posed with the opportunity or the chance to be able to extract the sample and then analyze and compare it. And you can do it with a gas chromatograph and a mass spectrometer. But it's inherently challenging when you get to analyzing tissues. As you probably know, it's very difficult to extract out organic compounds from very lipid-rich materials. A lot of the cleanup tools and approaches that you would use, like concentrated sulfuric acid or other things that you want to clean up and get rid of this oily matrix, natural lipids to look at your hydrocarbons, can also break down your sample. So yeah, can you fingerprint a sample that's in a tissue back to a source? Yes. Is it challenging? Yes, because A, you have to get the sample. B, you have to have a pretty good understanding of what may have changed. And then you have to get a good enough extraction and sample mass to make a match. But it gets very tricky. Something is beeping.
It's not you.
Is it me?
Oh, I don't think it's you. Hopefully, I think it's a phone.
Is it me?
No, not you.
Is it?
Is it okay. Okay, I think it's gone.
I still
all
hear
right.
it. Now it's getting
Wait.
really mad.
It must be you then. Yeah, that's a good idea.
I've never heard the sound in my life. I have no idea what this is.
Can you mute you? Can you mute yourself for a sec? I can mute you, and then we can see if it still sounds.
I have no idea. I've never heard this before.
Hold on a sec. Let me mute you.
You can just turn the volume down on the way.
Yeah. Do you still hear it, Chris?
Yeah, it's really intense.
Okay, it's you.
I have no idea. It is insane. I'm sorry. I don't know what's going on. I'm sorry.
Is it your thing above your, is it the smoke alarm or?
No. Sorry, I'm freaking out. I don't know what's going on. Oh, all right.
Okay,
So, the end result is that, yeah, you can fingerprint back from an animal tissue back to a source oil, and you might get a good match. Now, playing devil's advocate, if I was the responsible party, I was the one who was being identified as the spiller, I would fight tooth and nail on tissue samples, because by the time you analyze that tissue and you get a result, it's not going to be, there's going to be some variability. Now, it might be in some cases, but it's often very hard to make some strong cases when you look at tissue samples to trace back to a source oil. It's doable, but it adds a little bit more uncertainty. And I'm not a lawyer, but that's enough uncertainty that might change the civil and even the criminal, more likely civil, fines that are associated with it.
all right, Chris, why don't you go on?
Yeah.
Yeah, you'll get.
Yeah, so I got two more sections that probably each be like 10 or 15 minutes. I want to talk about the different roles and the different cultures that happens when you have a crisis. And, I kind of think about when you have an oil spill or any crisis, when it works well, when you have the least damages, is when you have some sense of meshing of gears, whether they're the responders, the media, government, the industry, the public, and academia. All these cogs spin at different rates, have different interests, have different levels of willingness to accept uncertainty and willingness to wait. And the end result is that if you want to have a successful outcome and you want to be able to make sure that it's the best possible outcome, you have to be mindful that each one of these groups has a different culture. They have a different value system. They have a different desire about what they want to do that they consider a successful outcome. So in 2003, I was an academic. All I cared about was publishing papers. 5 years later, the responder wanted to make a bad thing from getting worse. The public, this person wanted to know whether or not they should sell their house. And the media wanted to write a story about who made the big mistake. And the government official wants to get reelected and show that they helped. And the business person who was the spiller is trying to figure out a way in which they don't have to pay as much fines. I'm not saying any one of these folks are right or wrong, but if you're going to walk into a crisis, you have to be mindful that each one of these groups has a different value system and desire, what they call success, on different timescales. Superimposed on that is a certain sense of perception. Some folks look at an oil spill and they think that, well, you're just dropping some oil. You're basically dropping oil into the ocean. It's that simple. And that often happens and gets played out in the media. Oh, this isn't that hard. Why are they taking so long? This seems like nothing's happening. This happens all the time. The result is that in reality, as you know, when you have an oil spill or any type of crisis and you involve Mother Nature, you involve the ocean and the environment, everything gets complicated. In the case of you folks, when you were responding to the Express Pearl or anyone's, you had a very difficult event because it wasn't just some small little shipwreck or a little bit of cargo was lost. You had fire, you had a seasonal monsoon, you had a pandemic, everything going on. And often people who are on the outside are surprised about the decisions that are being made because they're not privy to all the knowledge. And this is one of the biggest challenges, is how do you get all the information to the right people so that they can make the right decisions? But sometimes it doesn't happen fast enough. And sometimes, even in worst case, sometimes it doesn't get shared with everybody. So you get this information gap. The information gap ends up creating a lot of questions and ends up having a lot more misinformation. The end result is that oil spills and other environmental crises are complicated, and they're much more complicated and confusing and challenging. That's often played out in the media and folks who think they're experts from around the world, like what I'm doing. Superimpose on that, every one of those different groups has a different willingness and understanding about certainty and time. For me, I want to publish a paper. I'm willing to wait a couple of years, but I know I have to be pretty certain. If I want to get published in environmental science and technology, my results have to be pretty certain. But it's going to take years for me to get all the data and all the quality control. But the responder is more willing to say, listen, I'll take more uncertainty if you can give me some information in hours. The point is that each group has a different comfort and willingness to accept uncertainty on the time scales. This is the big challenge, because it's not only a sense of comfort, it's also a willingness of when to act and how to act, knowing what you have in hand and when you might know more information. There's no happy ending, right? It's just this challenge of being aware of time, how much time you have, and how much certainty you need. And this is constantly resetting sometimes. Superimposed on that is this idea that science is going to save the day and it's going to be very clear. But, science can help out sometimes in a response during oil spills, but much more useful in the forensics and the damage assessment. But you always have to be mindful that, science is incremental and it's ever expanding and it's self-correcting, but it takes time and there's a certain sense of methodical aspects. Sometimes people don't want to wait, and yet that's what you need. Science is not built for speed, and it can be very frustrating in a response when people want information and they're not getting it because they can't get the results fast enough. My lab isn't up and running. I'm out of hexane. I don't have any helium, whatever it is, or we have to ship the samples to France. All of these things create lags in time, and science often needs more time. I will tell you time and time again, working on oil spills is the best possible outcome is when the people who are most likely going to have to work with each other already know each other. That you don't have to be best friends, but you have some sense of pre-existing relationship. And there's a former admiral in the United States Coast Guard who says, you don't exchange business cards at a crisis, which means that if you think a crisis is going to happen, you should know who you're going to meet beforehand when the circumstances are much less dire. Right? That any opportunity to be aware of who you might interact with, what their culture is, what their value system is, what they know, what they want to know, is much better to know before the oil spill happens. But this also kind of transcends into new technology. Often when there's an oil spill, there's somebody who wants to say, I can do this. I've got this new idea. I can use dog fur to clean up the oil. And, but they don't know who to call. They don't have anybody's phone number, right? And then maybe they call and they talk to somebody who's a respondent and they say, I got this great idea. And they're like, well, I don't know who you are. And I got to go to another meeting. And so having a pre-existing knowledge and pre-existing relationship is often the best way to get information to people as fast as possible. Timeliness in terms of the transfer of knowledge during a response is absolutely critical, but it's going to be fast, but it's going to find the right person. So even if you're the greatest scientist in the world and you could win a Nobel Prize every year. If you can't get your information during a response to the people who need that information to make decisions, then nothing happens. But you get a much better chance of transferring your knowledge if you know who might be there beforehand and you have a cup of coffee with them or tea, or you chat with them, you go for a walk, whatever, you'll have a much better outcome. Again, the other aspect is that often after 1 week, 1 day, 1 month, 1 year after an oil spill, they'll say, 1 year later, how is it? Well, you can give them a report about 1 year later, but oil spills don't have anniversaries. These crises don't have any anniversaries. It's just another time just ticks by. You know, chaos and recovery work on different time scales. And they work on different time scales based on what was impacted. You know, one area might be significantly impacted, but might recover in a week or 2 weeks or 3 weeks. Another area might be lightly oiled, but it was in the wrong place in the wrong time. It may never recover or recover at the level it was. So often somebody will ask, well, how's the Gulf of Mexico after the Deepwater Horizon? Well, what part? You know, is it swordfish or is it the beaches? Because everybody has a different recovery clock. By the way, I wrote a book on this. It came out about a month ago. And I talk about this. I had to shamelessly plug this. So the last thing I want to talk about is this idea of response versus damage assessment, especially from the science perspective. You can think about the science being done during a marine incident or oil spill, and you can break it up into a response, an assessment, a damage assessment, and a restoration. The size of these arrows along the horizontal represents time. So the response is pretty short, often relative to the damage assessment, but it's very intense. And then you have damage assessment and the restoration, which restoration is trying to make these impacted areas whole again. But there's a key point here is, one, damage assessments can start almost immediately. They don't have to necessarily be part of the response, but you can start collecting data or identifying areas that haven't been impacted immediately. So you can start a damage assessment and start identifying what levels of possible damages occurred within when the spill occurs, but you just have to be mindful that the response is still trying to drive the bus. They're the most important, trying to make a bad thing from getting worse. And they are much more willing to do things that are different and have a much more comfort with uncertainty. And I'm going to return to that again. Superimposed on all of this is the forensics aspect, which is trying to collect samples to prove who was the spiller, who wasn't the spiller, that the oil was recent released. It wasn't from a legacy spill that constantly comes up every once in a while. The key point is that I have 4 different words up here, and each one of those words has a different type of science, different type of turnaround, and a different set of stakes, especially from their quality control and the level of certainty. Just remember, a response ends when there is no longer actionable activities. So there was an oil spill 2 days ago, not far from my house, and the Coast Guard, it was in a local bay, and the Coast Guard went and flew a helicopter over, and they said, there's nothing we can do. You know, the oil is too thin. We're not going to put a boat out there because we don't think we will recover anything. We don't think anything's actionable. So the response ends when you can't do anything. And you especially have to be mindful that you're not going to hurt anybody. The damage assessment will go on as long as needed, or as long as folks are willing to contest and identify and see what was hurt or not hurt following the spill and how long it took to recover. And then you have the restoration, which is a little bit outside of my skill set, but it's having the knowledge to try to make things whole after what was impacted. I want to drive home the aspect of response versus damage assessment science. This is a huge issue that happens, that's misunderstood a lot in my world in the US. When you're in a response, more or less than not, you want to work with technology that's proven, that's fast, that provides useful information to the responders. It doesn't matter whether it's low or high tech. And in fact, it can be not, you can have a lower level of certainty. But whatever you do, whatever information that somebody generates, it's only as valuable as if it can get to the people who are making decisions, and that you can give some level of certainty. I have been involved with people who want to do the most advanced technology, and the only instrument in the world during a response, they want to collect a sample. But the information that they have doesn't really change the response. It does not help the decision makers put the best plan in place. So you can have the prettiest chromatograms, but it's going to have utility, it's going to be done fast, and it's going to provide, it's going to be find the right people. You find the right people by have pre-existing relationships and knowledge of who they are. That is the key thing. And in this case, you can do a great response science, maybe just using an analytical balance, or maybe a ruler, or maybe you want to get some sense of how much oil can evaporate. So you take some of the sample and you put it in a hot plate. Whatever information that you can use, if it's properly communicated, is valuable. It's all about trying to make a bad thing from getting worse during a response. But you got to get it to the right people at the right time in a manner that is useful to make meaningful decisions. On the flip side, damage assessment has much more luxury, right? But often the level of quality control, how robust it is going to be significantly higher. Because like it or not, we live in a litigious world. The certainty is going to be higher. There's much more money on the table. But still, you have to have a proven technology. And you have to show that whatever you do works. And I've got myself in the same trouble. That a lot of times, I want to use the most advanced piece of technology. And I skip steps. And I tell folks that when you want to analyze either during a response or damage assessment, start low. What's the lowest technology? What's the next step up? What is your research question? And keep going up. I've seen countless times where people want to use the most high tech, they get in it a value or a number, but it doesn't tell the whole story. It's complementary. And start a base, start with easy analysis that are understandable, accessible, and build your case. And if you need more high tech, then you get more high tech if you can do it. But try to get stuff that's proven, fast, available to folks, and then move forward as you build a story, especially on the damage assessment side. We're going to take a break. But whatever the case may be, you need samples. Right? And your samples have to have a provenance, and they have to be stored, and they have to be labeled. And you have to identify what type of analysis you're going to use, because there's countless amounts. And then you have to be mindful of the whole time. And, the whole time is that some samples in some type of sample matrices can't last forever, or not ideally last forever. So if you collect a water sample after an oil spill, you want to know how much benzene is in there. In the United States, you have 7 days to analyze it. After 7 days, it is thought that the integrity of the sample is lost because benzene is so volatile. And you might get a number, you might get a result, but it is not as well. The confidence is much lower. So you have to be mindful of, I'm going to grab samples. I need to know where they came from. I want to put them in the right jars. I want to do that with high quality control. I want to have a distinct labeling system, and I have to know what I want to be analyzing for, and I want to know how much time I have before I don't have as much certainty in the outcome. So Lini, this is like the end of part, kind of most of my talk, and I'm going to come back. These are my takeaways. Every oil spill is different. You have to be mindful of what was released. I mean, the volume that was released, the type of oil, and the location. That the type of science you do for a response, the type of science for forensics and damages are different. That if you can have pre-existing relationships, you'll have a better outcome. I didn't touch upon as much as I would like, but early predictions really come out to as bad as people usually predict, and that you will always struggle with time and uncertainty or your comfort zone. And you just have to be aware that if you want more certainty, you probably have to give up time. And that is a challenge that you will face when you're in these crises. So Lena, I can take any more questions here. The follow-up part is kind of a little bit of a lecture, but more I made it as kind of a working guide. So the images are not as sharp or crisp, but it's got a lot of information. So I was going to kind of skim over kind of some of the things that I think about when I'm sampling. But happy to take any more questions on the first part or the second part right now.
So Chris, do you want to take a short break, or is it too late for you, or what do you want to?
No, I can go through this, the sampling.
Okay,
Yeah,
so let's
it's
just
not
take
that.
like
Yeah, it only take like 10 or 15 minutes. I mean,
okay. So I think
why
what
don't
I'll
we
do,
take any questions?
yeah, we'll take some questions, and some people will probably get up and go get some tea, and they'll come back. But I'll make sure it's a short break for everyone.
Do
Okay.
you want me to come back tomorrow or tomorrow morning?
I don't. So we've got another thing tomorrow morning.
I mean,
So
you can do this PowerPoint deck that I have on sampling too. It's not that, you know.
what did you say?
You
Do you
can
want
do
me? Why don't you, I guess let's ask the audience, do you guys want, he can send me the presentation and I can share that with you, and you take a break now, or you just wait and listen to the minutes? More sampling. What's the, what would be? All right, why don't you continue and people can go get tea if they want to? What,
Okay.
those of you, those of them who.
Well, let's take
Yeah.
any questions if they have any, and then we'll just go through this kind of sampling.
Okay, Stuart Sandin from,
I just want to remind that we had a question yesterday. About how long to hold on to samples.
yeah, how long to hold on to samples? Like, when do you know? And maybe you're gonna talk about that next, like.
Yeah, I mean,
the-
no, it's a great question. You know, it depends on the analyte, right? So you could collect a sample of water, and if you wanted to analyze for benzene, which is a volatile chemical, you have 7 days. But if you wanted to measure for a chemical like pyrene, which is a semi-volatile chemical, you might have 21 days. It gets very complicated very quickly because oil is complex, and the different properties of the different chemicals dictates its sample integrity, which then dictates how long you can hold it. But the challenge for hold time, most cases, goes back to water samples and we call sheen samples, which I'll talk about. Most other samples, if you can get it into a freezer, there is no hold time. You can hold it as long as you want if you can get it frozen. But otherwise, water and surface sheen, you have to be mindful of what the chemical you want. And each one of these chemicals may have a slightly different hold time, and that's complicated. But that's just the way it is.
Flip side of that question was, what's the kind of legal thing of like, how long should you hold on to make sure you're protected?
Yeah. Well, I would hold on. I mean, Yeah, I mean, this is the great question, right? I mean, there's an oil spill that happens about every 4 to 6 months, and somebody will reach out to me, and the first thing I'll say is try to find a sample of oil. And if you can't get it from the ship, get a sample that you know was one of the areas that was impacted really close by. So it's the least weathered one. And then I'll say, what do you have for sampling? Whether you have aluminum foil, do you have glass jars? And more often than not, somebody will say, well, when this happens, they'll say, well, we don't have a lot of analytical facilities, so we're not going to collect that many samples. And my argument is to take as many samples as you can safely, if you can store them in a safe manner and make it traceable, and worry about whether or not you lose any sample integrity down the road, with the exception of the volatiles. My point is take as many as you can, especially early as you can, because if you treat an oil spill, it's like a crime scene, which it is. I mean, kind of like from, every time it rains, you lose some of your evidence. So my advice is to collect samples as best as possible, try to keep the integrity. Samples that have a lot of volatile chemicals, eventually, even after the whole time of 7 days, might have some decent data, but eventually, these chemicals will evaporate. But grab your samples and get good labels. Worry about whether or not you have the right instrument down the road. Don't worry about it.
Okay, Chris, why don't you do your second part? I'm
Yeah,
recording any.
Yeah, this
for
is,
one-
yeah, I mean, this is more just to share. And I'm going to polish it up a little and then it'll be available for you guys. Let me go back.
Yeah, I think it's now 1:30 a.m.
Okay, let me,
So if you
that's-
guys want to go to tea, that's fine, but I'm just gonna have him go. 'cause
this
I
is
just don't want.
literally going to take no time. So let me just get out of this. All right, I'm stop sharing. 1 second. All right, here we go. So I just want to talk through a few things. I made this for you guys, kind of like a field guide. Let me just put this in. No, wrong one. So we'll make this available. I just want to tweak a couple things, but just an idea about collecting samples, documenting them. Now, a lot of you folks might have already known this, but it's good to have this type of mindset about being and collecting field samples. My take is, if in doubt, take a sample. As long as you can do it safely and legally, grab samples, communicate, call people, try to figure out what type of jar you use. But the longer you wait, the less integrity you have in your sample as it's sitting out in the environment. Because every oil spill is different, you're not going to have, this is not the greatest experiment you're ever going to do. You may not have the affordable luxuries of controls and baselines and all these things that if you were designing an experiment, you would build in. You don't have that. You're working as fast as you can in a rapidly moving case. You do your best that you can do in a safe manner to whether or not you can help out during the response, you can do some level of forensics, or you can help with the damage assessment. But whatever you do, try your best and be mindful that it may not be perfect, but if you keep good notes, it's better than nothing. I go on a long discussion about why you would collect field samples. I think I've touched upon a lot of this already, but it's in here about why you would want to have field samples. It's pretty obvious for you folks. I just want to again drive home safety. No, we don't want to exchange blood for oil. So it's never worth it to go grab a sample. Then we're going to talk a little bit about type of residues, provenance, labeling, and things like that, that you guys might be better experts than me, but It's always good to say. I got a lot of font and a lot of text in here. No sample is worth your health. I have made some bad decisions trying to grab a sample, and I'm a little bit smarter now, but it's never worth it. And use a buddy system. Be mindful of exposure. Anything you can do so that you're going to go home safe. It's better that way. You don't want to eat the oil. It's kind of a joke, but now, if you are going to collect samples, you got to keep good records. You know, chains of custody, which are in most cases thought of as, you know, a complicated form, but chains of custody can be just a piece of paper that says, I collected this sample here and I'm giving a subsample to Mahini and signing it. If you want your samples to have meaningful value, you have to keep excellent records, and you want to keep as good a notes as possible. You want to take as best of photos and videos, any way that you can document, and you're going to have to be creative in some cases, but whatever you can do to keep your sample integrity and their provenance in place, you do it. And sometimes you don't have a fancy form, but if you have a piece of paper that you can write your notes on, and you say, you transfer a neat sample of oil from one place to another, then you take whatever you can to do whatever you can do in a safe manner. Now, this is what, when I think of a chain of custody form is you have all these samples, you're giving them to somebody else so that they can analyze them for you or store them, and you have time and date and what type of sample you want analyzed and what type of sample type it is and contact information. This is as good as it gets, but sometimes you don't get that, right? So you take whatever you can as best as you can in a safe manner. There are lots of different types of samples. I'm just going to throw them up here. You have to be mindful of each one of these samples and how you might collect them, store them. Original oil, I'm just going to walk through them. I can't underscore to you enough. The best science is going to come out if you have a reference oil. A lot of times samples are collected immediately after. Somebody might have it in their refrigerator. Ask. Can I have a sample of the oil? Make sure you get good records, get a good chain of custody. You will have that information. That is your baseline for all future comparisons. If you cannot get the original oil, get samples of oil that were collected very early after the event that had the least amount of weathering. Water samples, in theory, I could spend a couple hours on, but you have to be mindful of whether or not you're going to collect surface samples in the deep, a whole wide range of sampling devices. But in the case, the biggest issue for water sampling is, what are you going to store them in? Most cases, either glass or Teflon jars. Typical plastic you want to avoid because of some of the additives that are present. And then when you get into water samples, because sometimes the concentrations are so low, you have to start really building in your blanks and other levels of quality control. Getting accurate and solid water samples after an oil spill is hard because it's constantly getting diluted. And I'm going to send you a reference on that, but water samples are tricky. A little bit easier is surface sheen. And in the US, you can use a Teflon net. You literally kind of just clean the surface. You can use any type of absorbent. These Teflon nets that are here are useful because the oil sticks to it really well, but it also can wash off easily with solvent. This is a sample of me collecting sample off the USS Arizona Memorial in Pearl Harbor from this battleship, and the oil continues to leak. And on the right is a sample, and you can see I wrote in the whiteboard behind, I had a discrete label. I kept time and when I put the sampling net into the water, when it was out. I have who collected it with me, and I have, if you can see, there's a white jar on the background. That's the sample ID that I gave it that matches what's on the whiteboard. And if you look to the left, you can see some gray tape in a bag that is the same sample label. And so before I took that net off to put into that jar, I took that picture to ensure that my labels all overlapped. I had a sample ID. I knew when it was put in, where it was out, and I had it also knew where I collected it. Point of the matter is I took multiple lines of approaches to make sure that I had a traceable outcome. Sediment is another one of these areas that you could talk about for hours, whether or not you're going to go for a surface, coring, what type of device. The upside for most cases for collecting sediment samples is that if you can keep them frozen, you can keep them for as long as possible. Hold time is at a minimal. Most cases, when you're thinking about sediment coring, you do have to be mindful of carryover. So you've collected a sample with your coring device in a really contaminated area, and then you're going to go to your background area thereafter. You want to make sure you're cleaning it in between. So you always have to be mindful of the quality control, proving that what you see is not a sampling artifact. And the areas where you can get the biggest artifacts are in the water and in the sediment when you transition from clean to dirty areas. And then you have all these ranges of, you have blobs, and they can be really sticky. You have, after Deepwater Horizon, most of the oil that was found was really these kind of oil sand patties that just kept coming up and coming up and coming up on the beach for years. But surprisingly, they were not too weathered, and they were pretty traceable when they were when you were in the sand. You can scrape off rocks. Gets tricky, but you can collect samples from rocks as long as you keep good records. Interestingly, a lot of times samples that are on rocks are a little bit more weathered because of the heat from the rocks, and you end up getting a little bit more weathering, kind of in most cases relative to anything else. And now you get into oil vegetation. Again, now you have to be mindful that in the process of trying to collect your sample in an impacted area, are you making it worse? So yeah, you want to go collect some of that oiled marsh, but is it worth bringing all your gear and your bags and your shovels to go out there? So you just have to be mindful that in the process of trying to do your science, you're not making things worse off. Again, for animals, I would really defer to your local experts and your local policy for so many reasons, both because you can get hurt, but also because of the legal aspects of it in the US. If you see an oiled animal, you call, the response, and they will come and take it away. These are tricky because it really pulls at your heartstrings, but you have to be mindful that also that an oiled animal is also a dangerous animal. Again, you can collect samples. This sample on the left is that an area in San Francisco Bay after the Costco Busan was an area that made a lot of teapots and coffee cups and saucers, and a lot of the oil stuck to these old pieces of broken up old clay. Or you can have oil bottles. If there's a possibility that you can get some value, you collect them. And I'm going to talk just briefly for a couple more minutes. You have to be aware of some continuum of confidence, that there are times when you're going to collect a sample and maybe you don't have every piece of information, but you have some. You take it, but you just have to be mindful that you might not be as confident in the sample you have because maybe your provenance isn't as good, or maybe you won't be able to put the sample on ice for a couple hours. But as long as you keep good records, you'll be okay. But you just have to be mindful that, again, oil spills are not perfect for collecting samples. You do what you can as best as you can without getting hurt. Again, this is me going off about continuum of confidence, whether or not maybe you only have the location, or some cases you have everything. You have photos, you got video, you get eyewitness, you get all this type of information, and that's great. But sometimes just knowing a little bit is going to provide some useful information. So you take it, but you're just mindful of what you have and put that uncertainty into your calculus. Again, you can have, this is a whole list of possible materials you could use. Lots of folks sample differently. When you have a lot of different samples, it gets a little bit trickier, and you might use more barcodes or QR codes. For me, when I work on, and I'm kind of a small operation, I try to create my samples to be distinct, and also that when I see them, I know where they came from. So in this case, I have Peru and Mauritius, but some type of qualifier, the month, the year, what sample was collected on what day, and maybe some more information. The key point is create sample IDs that, unless it gets really a lot, that have value to you when you look at the sample ID, it can help you place context. There's nothing worse than looking at sample number 23 and sample 24, and that's the only thing you have, and you're trying to compare chromatograms. But when you have a sample ID that also builds in some information, it becomes very valuable. So if you can, try to provide a labeling protocol that has value and embeds information. And this is just one set of examples that we used studying this Texas spill. We can go on along more, but the whole idea of sampling and packaging, you just got to be mindful of handling things, storing them. And you can see this PowerPoint later, but I went through and in my house, I was helping this person out in Mauritius. She wanted to collect samples for me. So I did this from my office, and I walked her through about how you would collect a sample and collect it and put it in some aluminum foil, because all she had was aluminum foil. And I walked her through each step, and then you're going to put a label on it. And this, I was pretty meticulous with her because she was nervous. But the point was that we had a discrete ID. It was wrapped. I was avoiding cross-contamination, and I was making sure that my sample integrity would last as long as possible. And I just went through this at length just to give you a sense that good sampling is great, but you got to have good labels. You got to have good chains of custody to get the most beneficial outcome. So I have lots more tips. This will be available to you, but I don't want to impinge on your tea anymore. So I'll take any other questions, Leanie, or I can respond back more from email too.
Great. Thanks, Chris. Are there any quick questions for Chris before we break?
And I can respond later too, Leanie.
Okay, yeah. Well, thank you, Chris. I know it's super late, so
Yeah,
yeah, good night, or I guess good morning.
that's fine. Thank you so much. I apologize I wasn't there.
No, and sorry about the technical stuff. Thank you.
Don't worry about it.
Okay. All right, we'll be in touch. Thanks, Chris.
See ya.
Bye.